Good morning, everybody. First of all, I want to thank to be invited to this seminar, and also I'm very grateful for these 3 days of visiting of the different labs here in France, because it was really interesting, and we hope that it could be fruitful for collaborations in the future. And my presentation is about the challenges and the tools that can be used for the energy and environmental improvements of built heritage. As Vanya was saying, I'm part of the lab of the Institute of Heritage Culture that deals specifically with the conservation and enhancement of historical buildings. So everybody, I mean, all the people that preceded me were talking about the importance and the value of cultural heritage as a driver for sustainability, and also as a topic for conservation to prevent the risks of cultural heritage. And from this point of view, energy efficiency is began to be recognized as a strategy for protection, especially as regarding buildings as well. Versailles is a very special building, but still energy efficiency, so the reduction of consumption can help the use because it reduces costs, and so it can enhance conservation. And especially in the Italian debate, the term improvement is often preferred to the term efficiency, because efficiency is linked to regulatory requirements, while in the case of historical buildings that are so unique, very often there is no threshold that should be reached, but the buildings should be improved to manage to get the best thermal conditions with the least energy consumption. Environmental design and conservation shared a lot of methodological aspects, such as this transgenerational time span, like that we have a very long time to work, and also interdisciplinarity. That is one of the key points of this seminar. And also the study of the bioclimatic behavior of historical buildings. It's not only important in terms of knowledge, but it also helps to understand how this building function passively with a very strong connection to local climate. And so, as Alessandra Bonazza was saying, we could learn from the past. We could learn how this building works, because we can enhance this behavior for our goals nowadays. However, thermal performance requirements are different now, and also incorrect uses and climate change, this was discussed a lot this morning, undermine this passive behavior. So even the understanding and enhancement of this behavior, and also, well, new actions that are needed necessitate advanced method of energy improvement that are specific of historical buildings. So some of these tools and challenges, I mean, these tools that are a challenge in themselves that we work with and that we consider very promising are heritage building information modeling, building performance simulation, and the coupling of the two. So BIM is the acronym of Building Information Model, and the idea behind is the definition of the a digital representation of the physical and functional characteristic of a building that represent an information system. So combining not only geometry, but also semantic information, as Grazia Tucci was saying. So the 3D representation of building elements is associated with a dynamic database of information. And this is very interesting for built heritage, because built heritage required a lot of data coming from different experts in different times. And so the production, but also the organization of this information is key. A BIM process specific for historical building that is called heritage BIM has the aim of provide an information repository for all this data. For the production of the data and the management of the data that could be accessible by experts from different disciplines. So the idea is to have a 3D model that also contains information. The objective is to have a tool that could be used by several experts, but at the moment, well, the software and the tools are not ready for this, but still there is a lot of work that can be done even with manual procedures or workarounds. These are some of the, well, this was supposed to be a video, but these are some of the activities that are integrated in the idea of BIM. BIM is not a software. BIM is a methodology that comprises a huge amount of software and activities for the digitalization of buildings. Simulation, building performance simulation is a methodology based on the creation of a behavioral model of a building that can represent some phenomena that can represent, analyze, and simulate phenomena in the real world, of course, with simplifications. And we are working mainly with simulation of energy and of course of thermal comfort, because energy efficiency deals with the reduction of energy consumption, but to get the thermal comfort that is needed. And in the case of built heritage, this technique is very interesting also because it could allow to analyze before the effect that intervention on a building can have also on critical conservation issues, for example, on decay phenomena, on moisture, and so on. However, this tool is still not widespread for built heritage for many reasons that are related also to the complexity of historical buildings that are not well represented by methods that were designed for contemporary architecture. And so, for example, the complexities of the geometries involved, the total lack of standardization, and also the specific behavior of some historical architectural elements, for example, the massive behavior and the importance of moisture transport that masonry has. Well, a good HBIM model should already contain much of the data that is required for performance simulations. For example, data on the climatic systems and on the envelope. So the interoperability between the two environments could save time and costs. But this integration is still very complex in its infancy because of both the complexities of HBIM models and the simplification of assumptions of energy modeling that are not very integrated into HBIM. Therefore, there is a requirement for a lot of manual modifications. And another problem that was discussed before in the discussion is the dialogue between experts. So the idea to find a way to make all experts understand each other, but also working within their comfort zone. Well, we are working with a workflow that, even given the complexities and challenges of these two tools, tries to put them together and integrate them to enhance the energy improvements of built heritage. Actually, the workflow is with these differences, is very similar to the Fresco workflow, because it's based on data gathering with geometric surveys and analysis. Then all this information, because the knowledge of the building, of course, is the basis of any intervention. Then all this data should go inside the HBIM platform and of the building. Then the current condition of the building should be represented inside the model, should be calibrated and simulated. to understand the energy and environmental behavior of the building as is, and on the base of that, design solutions that are compatible with his heritage significance can be designed and tested for efficiency, time, and cost constraints. And we applied this workflow on a case study in Rome, Palazzo Maffei Borghese. That's mainly used as an office, so as a very special needs also in terms of thermal comfort. And I will be very brief. So the historical and architectural analysis was the basis of the analysis phase, because also gives us a lot of information on construction techniques and therefore on the on how the envelope was made. Then we did a geometric survey. This was a small video, and general conservation state analysis, of course, based on a photogrammetry survey of the facade to have a higher definition, and many energy analysis. Quantitative analysis is a heat flux measurement to understand the envelope. Thermography, that is very interesting for us because it's an analysis that is used for both conservation and energy analysis, because it helps understand constructive techniques, decay phenomena, thermal bridges, and so on. And also an environmental monitoring. In this case, we did a 1-year environmental monitoring on a group of rooms in the building that had very special use. And it was very important to calibrate the model because even if we had energy bills, this building has a very complex type of use. And so this was really paramount to have enough data for calibration. And all this information was integrated inside the HBIM model, because it was also referenced during the analysis phase and then for the simulation. This was a short video to show you the BIM model that is not just a 3D model, but it has all the information on building elements, especially on the envelope, that was then exported for the simulation phase, and then there was a dynamic simulation performed on the building. And based on this simulation of the current condition of the building, we proposed intervention following, of course, compatibility criteria. This is a list of the interventions, but the most effective ones were intervention on the envelope. Some parts were new, so we could work with insulation, and a lot of interventions on the conditioning systems. And these are the interventions were organized into 3 scenarios based on the payback time. And as you can see, even if this is just still in the modeling phase, even the short-term scenario has a very, very high energy consumption reduction. And in this particular case, it is because the use of the building was totally not taken into account by the HVAC system. So just optimizing the conditioning system, make it optimized for use and also for the passive behavior of the building, allow us to have a great energy consumption reduction. And this is the most ambitious of the interventions, the one that will never be repaid. And this the idea of having a buffer space on the cloister of the building, because the cloister is also a very, very important typical architectural feature for the bioclimatic functioning of historical buildings. And so this buffer space that is glass and then has a photovoltaic cover could be used and this everything can be opened, and it can be used in winter to prevent heat loss, and in summer to manage ventilation, especially nighttime ventilation. This is, well, a view from the inside, and this workflow has been disseminated. This workflow was part of an NEC-BC Med project. So again, sharing. And it was published as a guideline to use the workflow, was published on the Zenodo page of the Institute, so it's open access, and you can, we will very be happy if you can use it. And also a book has been published last month about the entire process and the application in this European project. Thank you very much.